All right, let's just jump right in. If you're a dev who's ever played around with an AI coding assistant, you know the feeling, right? That initial wow moment when you type some half-baked idea and poof, a whole project structure just appears. It feels like real magic. But then, well, then the morning after comes. The magic wears off, you start realizing the AI just made up a feature you never wanted, the logic is all over the place, and congratulations, you've just inherited a mountain of technical debt. So in this explainer, we're going to get into how you stop being the AI's cleanup crew and start being its architect. And hey, if deep dives like this are your jam, make sure you hit subscribe so you don't miss what's next. This quote right here is the absolute truth we have to start with. It's really the core idea of everything we're about to cover. You know, that fun experimental thing we all do, just vibing with the AI, kind of tossing ideas at it to see what sticks. It's awesome for a quick prototype for sure. But the second you try to build something that needs to last, something that needs to scale and be understood by other humans, it just completely falls apart. So what is this vibe coding thing really? Well, it's pretty much the default way most of us use these tools. You give this incredibly powerful, super literal agent a fuzzy prompt like, hey, build me a user profile page. And then you spend the next 3 days fighting it, fixing its mistakes, and cleaning up the mess it made when it inevitably guessed wrong. It is, without a doubt, the #1 cause of AI-generated tech debt, and it leaves you with code that's fragile, a nightmare to test, and almost impossible to refactor. All right, so here's our game plan for fixing this. First, we'll really unpack the vibe coding problem. Then we'll look at a spec-driven solution that flips the whole script. After that, we'll talk about the absolute key to making it work, clarity. Then we'll walk through a 5-phase workflow step by step. And finally, we'll talk about how this all leads to you becoming the AI's architect. Look, that rush of getting code instantly is amazing, but the hangover is brutal. The minute you go from a simple script to a real feature, vibe coding shows its true colors. The AI starts imagining API endpoints that don't exist. It completely forgets the logic it wrote 5 minutes ago. And before you know it, you are drowning in this tangled mess of code that's honestly harder and way more expensive to fix than if you had just written it yourself from scratch. So what's the antidote to all this chaos? It's a method and a tool called GitHub Spec Kit. And what's so cool about this is the mental shift it forces you to make. You stop asking the AI for code. I'm going to say that again. You stop asking the AI to write code for you. Instead, you prompt it for things like structured specifications, technical plans, and super detailed task lists. And only when you've reviewed those docs, polished them up, and decided they're perfect, only then do you give the AI the green light to actually write a single line of code. Okay, but before we even talk about the tool, we have to get this one thing right. We have to learn how to speak the AI's language. And that language is one thing: absolute clarity. You know, the biggest point of failure every single time is human ambiguity. We have to get this through our heads. AI agents aren't our coworkers. They have no context, zero common sense. They're just unbelievably powerful, hyper-literal prediction machines. I want you to think of them like a genie in a bottle. They will grant your wish exactly as you word it, including all the terrible loopholes you didn't think of. Our job is to leave no loopholes. So how do we get that kind of surgical clarity? Well, the first rule is to define the negative space. You have to be explicit about what the AI should not do. A prompt like, make the API secure, is just asking for trouble. It's basically an invitation for the AI to grab some random library that might be full of holes or use a pattern that doesn't fit your system at all. But telling it exactly which IDs to hide and which crypto modules to use, now that is a clear, safe, and unambiguous command. Next, you need ironclad data contracts. Something vague like users details is totally useless. The AI might decide on a whim that a user needs a favorite underscore color field. It might make the email fields way too short or forget to add a timestamp. The clear prompt, though, it defines the exact schema, the data types, constraints like unique, and even default values. There is absolutely zero room for guesswork, and that means your database and your code will match up on the very first try, saving you from those awful database migrations down the line. And finally, you gotta have deterministic constraints, especially for all the weird edge cases. Handle errors is just a lazy prompt, and it leads to a terrible user experience. The AI might just let it crash or spit out a generic, oops, something went wrong. A professional prompt defines the exact behavior. Which status code triggers the logic? What's the retry strategy? What's the final fallback? Seriously, this level of detail is what separates a fragile toy from robust, production-ready software. Okay, so with that idea of clarity locked in, let's see how GitHub Spec Kit actually puts this into practice. This isn't some chaotic back-and-forth chat session. No, it's a very strict, 5-phase workflow that takes you from a fuzzy idea all the way to flawless production-grade code. And here they are, the 5 phases. Think of this as your new mental model for working with AI. You've got constitution, specify, plan, tasks, and finally, implement. Each one of these phases creates a document that feeds into the next one. It's like a chain of evidence that guarantees the final code is exactly what you wanted from the very beginning. Let's break them down one by one. So, we kick things off with the constitution. This is where you set up what I like to call the laws of physics for your project. These are the non-negotiable fundamental rules for your entire code base, and you define them right at the start. The whole point here is to lock in your big decisions so the AI can't just wander off. You declare your tech stack, your linting rules, security policies, testing frameworks, all of it. The AI then spits out a markdown file, constitution.md, which becomes its permanent, unbreakable rulebook. From this point forward, every single thing the AI generates has to follow these rules. It can't just randomly decide to use Bootstrap instead of Tailwind. All right, on to phase 2, specify. Now that our laws of physics are set, we define the actual intent. This phase is so important because it forces you to think like a user. This is all about the what and the why, the business logic, not the how it gets built. So you just describe the feature in plain English, just like you were writing a user story. The AI takes that and generates a formal spec.md file. And here's the brilliant part. There's an optional command /speckit.clarify. If you think your spec has some holes, you can run that, and the AI will actually ask you questions back, like, hey, what are the size and format limits for the avatar? It's like having a perfect business analyst sitting right next to you. Okay, now we hit phase 3, plan. This is where we take that business-focused spec and turn it into a real technical blueprint. Now we are officially talking about the how. So you give it some high-level architectural direction. Then, the AI reads your constitution and your spec and generates plan.md. This is a super detailed document that maps out the entire file structure, the data models, the API endpoints, all of it. And there's even another cool optional command, /speckit.analyze, that basically works like an automated code review, checking the plan against the spec to make sure no requirements fell through the cracks. We are getting so close. Phase 4 is tasks. You've got the rules, you've got the requirements, you've got the architecture. Now you just need a step-by-step roadmap to actually build the thing. And this step is just beautiful in its simplicity. You literally just type the command. The AI reads everything we've made so far and generates tasks.md, which is a complete checklist for execution. It turns that big, scary architectural plan into a bunch of small, manageable steps. And it's even smart enough to figure out which tasks can be done in parallel, which is a huge boost for productivity. And now, the moment we've all been waiting for. Phase 5, implement. This is where the magic happens. But it's not random, chaotic magic anymore. It's controlled, predictable, engineered magic. With one single command, the AI gets to work. But here's the key. It isn't guessing anymore. It's just methodically executing the plan you gave it. It reads the constitution for the rules, the spec for the requirements, the plan for the architecture, and the tasks for the exact sequence. It generates everything, the production code, the tests, the docs, and when it's done, you can run /speckit.checklist for a final QA rundown to personally verify that the code perfectly matches your original intent. So if you haven't picked up on it yet, this whole process totally changes your job description as a developer. You're no longer reacting to what the AI spits out, desperately trying to fix it. You are now proactively directing its work from a high-level, strategic position. And this right here just says it all. The vibe coder, at best, is a code typist. Your job is fixing syntax and cleaning up garbage. But the developer using a spec-driven workflow, you become a true technical architect. Your job is to focus on user intent, to define clear boundaries, and to design strong systems. You get to spend your brainpower on the high-level stuff that really matters, not chasing down bugs from a hallucinating AI. So I'll just leave you with this one question to chew on. The next time you sit down to work with an AI assistant, which one are you? Are you playing the role of the typist, or are you the architect? Because honestly, the answer to that question is going to define not just the quality of the software you build, but the entire future of your career in this new age of AI.